All right, so let's talk about DDIs again. This is, I'm Daan, System D mkosi maintainer, and I work at the Linux user space team. I work at the Linux user space team at Meta. So, what is the motivation for mkosi, which is System D's image builder? Well, the first one is the same as repart. How do we build those DDIs that Leonard and Luca keep talking about? We know that System D repart can build us the disk images, but we still need to somehow get the files that we put into them. So that's where mkosi comes in. How do I test my risky System D bit 1 contribution? So this basically means, you find a bug in System D. You're a good open source citizen. You clone System D. You write a patch to fix it. If you build System D and then install it to your laptop and you write a bug and it crashes, your system is bricked, so you can't do that. You can have a test system and install it there, but then you can also break that if your patch has a bug. Or your patch might be right and something else in System D is just broken and you still brick your system. So you don't want to do that. You want to run it in a VM or in a container, so that if something goes wrong, you just kill the VM or the container and you continue, you fix the bug and it's like nothing ever happened. If you get a bug report for a user that's running OpenSUSE, you're on Fedora, and the bug only reproduces on OpenSUSE, then you need a way to reproduce an OpenSUSE system so that you can reproduce the bug, test it with your fixed version of Systemd, and then push the fix. You want to build an initrd, you want to do it without Drakit. How do you do that? Well, you can actually do that using mkosi as well. And assuming you buy into this fancy blog post that Leonard wrote about fitting everything together, so Leonard's ideal view of a Linux system, then you need something to build that system. mkosi is intending to be that as well. There's a bunch of all other stuff it can do. And specifically, you want to do all of that stuff for, ideally, whatever distribution you are using, right? If this tool is just Arch Linux specific and you're running Fedora, well, then it's not really useful for you. So it should ideally support all the popular distributions so that everyone can use it. So what is mkosi? Initially, I think Leonard wrote it in 2016 for testing Systemd, basically. So I think he just bricked his laptop one too many times and he decided not again. And that's when mkosi started to come into existence. Then in 2020 or 2021 is when I started contributing to Systemd. So I read a hacking guide somewhere about, hey, use mkosi to test your changes. I tried it. It wasn't that good. So I started fixing it. Eventually, that's where I started. So it got a bit out of control. And pretty much every line in mkosi has now been rewritten by me in some form or another. So mkosi builds you Linux images. So the quickest way to get started is basically the below command line. So you specify a distribution, you specify which packages you want to install. You can enable auto login, and then you can specify a verb, which is build, boot, qemu. There's a few. We'll discuss them. In this case, we do qemu. And what do you get if, for example, you build Arch Linux? You get a shell, a root shell in a Arch Linux VM, right in your terminal, no separate qemu window or anything. And you can do whatever you want in there. And then if something goes wrong, well, it's just a VM. You just throw it away and you can rebuild it from scratch, and it's like nothing ever happened. Of course, again, doing it for just Arch Linux is pretty boring. So we don't just do Arch Linux. You can get this root shell on anything: CentOS, Debian, Ubuntu, OpenSUSE, Fedora. Whatever you can think of, you can just get a root shell. And the only thing you have to change is which distribution you make the image for and the package names, because they're not always the same between distributions. A lot of them are, though. So if you're depending on which packages you need, you don't even need to select distribution-specific packages. Everyone likes demos, but I am not going to invoke the curse of the live demo, so let's look at a video. So this is basically running that command. We start downloading packages. In this case, they're already cached, so then we start installing them. This is basically just running pacman. Eventually, that's done. Then we run a bunch of tools, systemd tools mostly, for like presets and stuff. Now we're running repart to generate the disk image. This is using the minimize option, so it populates the file system twice to figure out the minimal size. Then we start building an initRD, which is, again, installing packages. There's no Drake here, so building an initRD is just running mkosi again. We just package it up as a CPIO instead of as a disk image. There's some mod info. There's the CPIO archive. Then we generate the manifest, and then eventually we start booting it in QEMU. So there we go. Wait a little bit, because this is running, I'm not sure, yeah, this might be running a debug systemd version, so it's a bit slower. And eventually you get your root shell. There's a bunch of services running, and then you just shut down again. So yeah, to show what was happening in the demo, first we just parse configuration, then we start by invoking the distributions package manager. After that, we run a bunch of systemd tools. First, we install the bootloader. So we support primarily systemd boot. I recently added back support for grub as well, both in BIOS and in EFI. Then we run all the various systemd tools. So there's quite a few, like first boot to set the host name or the root password, or all those things. Preset all for applying systemd presets and a bunch more. Then we build an initRD. And yeah, basically this starts again from the front. So we parse the initRD configuration. We install packages for the initRD. There is no bootloader in that case, so we skip that step. We run all the tools again, and then we have our initRD packaged up as a CPIO. We can use that to generate the unified kernel image with UKFI. Then we generate the disk image using a systemd repart, and finally we boot it in QEMU. So if you noticed, I was running mkosi without putting the sudo in front. This is not because I run as root on my laptop. This is because mkosi does not need root privileges at all. So how we do this is, well, there's two things to do, or there's two things to worry about, two things that need root privileges when you're generally building a bootable disk image. One is actually making the disk image. My previous talk, I explained we have systemd repart for that. So no root privileges needed anymore there. And then there's the part where the distributions package manager needs to think it's root, because otherwise it won't do anything. Because we can't be actual root, what do? We use a user namespace. Unfortunately, we can't use just a user namespace, because a package manager needs to write not just files owned by root, it also needs to write files owned by random system groups. Like there's a utempter is a good example. It wants to be owned by the utempter system group. So we need a full map of UIDs in the user namespace so that the package manager can make sure that the right files are owned by the right group. So there's like two tools shipped with shadow utils, new UID map and new GID map. And these are basically allow you to get one of these UID maps without needing to be root. It is set UID. Leonard does not like that, but it's the best we can get. So that's what I use. Then we get into the user namespace. There we run mkosi. The package manager is now happy because it thinks it's root, even though it's not. And then we run systemd repart from within the user namespace, so that all the makefs tools also think that all these files are actually owned by root when they get put into the file system, even though they're actually not. So you get a disk image with the files in it having all the right permissions, all the right UIDs and GIDs, without ever needing to be root on the host file system. What do we need? It's just a Python script, Python 3.9. We use bubble wrap for a lot of mounting and such. So overlay mounts, bind mounts, and all that. We need a package manager, of course, depending on the distribution you want to build. Interesting is that for Arch, we do not use packstrap. You just need directly pacman. And for Ubuntu and Debian, we do not use the bootstrap. We run apt directly to build the image. So the bootstrap is never even involved. And then for bootable images, we need UKFI, and for disk images, we need the systemd repart, of course. So how does configuring mkosi work? This is, again, pretty much like what systemd does. So it's ini file syntax. where you specify all the settings. So you can configure the distribution, the release to use, which packages to install. We support drop-ins, so you can have a mkosi.conf with the main configuration, and then mkosi.conf.d with all the drop-ins. And one interesting thing we do is we allow conditionally including specific configuration files. So this is with the match section. So if your configuration file has a match section, we read that first, and this behaves like pretty much the same as systemd conditions. So you can do or, and negate them, and then if all the matches in your match section match, then the configuration file is included. So this allows you to have distribution-specific configuration files. In the example we show here, this configuration file is only applied when building a Fedora image. So yeah, we do the drop-ins. So this is basically how this looks. This is straight from the systemd mkosi configuration. So we have a bunch of distribution-specific drop-ins. Each of those has a match section to only apply it on that specific distribution. So we have a bunch of settings that you can configure in your configuration files, but one problematic part of configuration is when it comes to package managers. So because we need to support a bunch of different package managers, Pacman, DNF, apt, and zipper. All of those package managers have a bunch of specific features that are specific to that package manager. And that if we had to implement all of those in mkosi, we would end up with a whole complexity of and a massive amount of options to be able to support all of them. So what do we do instead to make our lives a little bit easier, but still expose all of these features? You can specify a so-called package manager tree. And basically, if you give us one of these trees, we go look into it for configuration files at canonical locations for the package managers. So for example, you can have a package manager tree with etc apt, apt.conf in it, and we will pick that up and we will pass it to apt. And you can pretty much take any other package manager configuration file, put it in the package manager tree, and we will pick it up automatically and use it. So you can use that to configure apt version pinning and the preferences.d stuff for apt. You can add new repositories for DNF. You can add a dnf.conf file. Whatever you want, really. We pick it up from the right location and we pass it to the package manager. So you get full control over how you configure the package manager when building the image. So we don't just have these package manager trees, we have a few more. So there's the base trees, which is basically when you say, I don't want to start from scratch when I build my image. I want to start from a specific base tree and then build on top of that. So in this case, we don't bootstrap the distribution from scratch. So instead, we just take what's given in the base tree and we just install extra stuff on top of that. The skeleton trees are basically when you have a package manager tree, but you also want that package manager tree in the image. This is when you want a package manager in the image. And you want the same configuration to be used when building the image, but also when you run apt again after booting into the image. So a skeleton tree is basically a package manager tree that's also copied into the image. The extra tree is applied after we have installed packages. And this is where you put all the random crap that you need on top of the distribution itself. So the picture here is an example of the extra tree of the mkosi image in the systemd repository. So we have an issue file in etc. We have a few repart configuration files. We have some journal configuration and a script, a service that basically checks if there are any failed services and shuts down with an error code if there are. So basically anything you want that's not in the distribution or in a package, you just put it in an extra tree and it gets put on top. So whatever you want, you put it in there. And then finally, there's the tools tree. So because like for the dependencies I showed were to, you only need a few dependencies to build just a directory image. But then if you want a bootable image or the disk image, or you want to like have extra file systems or do other fancy stuff, we need a lot more dependencies. you might not want to install all of those dependencies or even have all of those dependencies on your host system, right? You might be running mkosi on a CentOS 8 system where there is no systemd rebar 254, or there is no UEFI 254, or there is no makefs.betterfs. All of that is missing. But you still want to be able to build images maybe on those systems, right? So what can you do? You can have mkosi build what's called a tools tree. So you use mkosi first to build a directory image of whatever distribution you want. You only need package manager, Python, bubble wrap, and core utils for that. And then you specify that as the tools tree. And we suddenly, for the full image build, where you're building the bootable disk image, we go and look up all our tools in the tools tree instead of on the host system. The way we do that is by taking the /user directory from the tools tree, and we mount that on top of the /user directory from the host. And suddenly every tool that mkosi runs is coming from a Fedora Rawhide image, even when you're running on CentOS 8. So this makes it, one, possible to build on all the distributions, and also makes it a bit more reproducible, because you can ensure that the image is being built from a specific distribution instead of whatever is running on the host system. So as I mentioned already, we run a lot of tools on the host itself, right? Generally, this matters mostly for apt, for Debian and Ubuntu, because the way you generally build images with those is you first run the bootstrap, then you get an image with apt inside of it, and then you change root into that image and then run apt in there to install more packages. If you're familiar with Docker, there was another talk here that said a lot of Docker files run apt update in the Docker file. So that's basically what we try to avoid. We always run apt on the host and have it operate on the root directory. And why is this nice? Well, you don't need apt in the image, right? You can build an image without apt in it. So you save on space, you save on complexity, and then if you intend the image to be used as an actual image, so read-only, you're never going to install updates or whatever, so you don't really need a package manager, so you don't have to install it. So we support incremental builds. So if there's a cache directory defined, then we use it as a package cache for sure, so you never download packages twice unless there's an update. But installing packages itself is also not exactly fast. So what we can do is we can basically, after installing packages, take a snapshot of it, save that somewhere, and then when you run mkosi again later, it sees we have a snapshot cache already, and we just copy that and work from there and don't install packages again. The cache invalidation for this isn't exactly amazing, so we do notice when packages are removed or added to the mkosi configuration file, but we don't yet do very granular tracking of all the inputs to decide if we need to rebuild the caches or not. So often you still need to do manual cache invalidation, but eventually I'm hoping to somehow fix that so that if there's one change in the inputs, we rebuild the cached images. But that's yet future work. So scripts. So we're very aware that no matter how many settings we add, there's always going to be something you want to do that isn't supported. So we support hooks to allow you to do that. So you can specify scripts, and we run those if they are defined at various points during the image build process. So the prepare script is invoked before we cache stuff. So if you need to download and install extra stuff that needs to be cached, you put it in the prepare script. The build script is for building software. This is when you use mkosi in a development context. So in systemd, we have a build script that will build systemd from source and then install it into the image, which means we can get an image with the latest version of systemd, which we can then boot in a VM for testing. Post-installation script is like the extra tree, but for stuff that doesn't fit into files. So whatever random stuff you need to do after the packages are installed, you do that in there. And the finalize script is invoked at the very end. So if you need something to do something that's absolute at the very end, you put it in a finalize script. These scripts run on the host. Like I said, we run all tools on the host, which for scripts gets a bit more scary because if you're running as root, which we still support, you can accidentally remove files from your host, which you absolutely do not want to do. So to prevent that, we mount a bunch of stuff as read-only when we run the scripts to make sure that even if something goes wrong, you're not actually breaking your system. The build script, so some more information about this. Generally when tools like Meson, the autoconf stuff and whatever, you generally want to run that from within the image context, because otherwise you need to specify the image as a sysroot, which gets very complex very easily. So generally, you want to run those tools from within the image itself. So we provide, when you run a script, we provide an extra helper script, which is called mkosi change root, which basically puts you inside the image. So in the case of this build script, which is a simplified version of the systemd one, the first thing we do when we run the script is we use the mkosi change root script to make sure to re-execute the script inside the image. So that means from that point onwards, we're in the image, and we can just run meson like we normally do, without having to start worrying about cross-compiling and setting sysroots and all that. So the mkosi change root makes it very easy to do. We also add a script for every package manager we support that has the same name as the package manager. So if you run apt or pacman or whatever from within a mkosi script, you're not actually running the actual apt or the actual pacman. You're running a script that we put in the pad, and that basically calls pacman or apt with exactly the same options that we call it with in mkosi. So if you do an apt get install from a mkosi script, it will automatically install into the image directory instead of trying to install to your host system. So this makes it very easy to install extra packages if you want to do so in a build script. The other thing is that because we just put a script in the pad, this doesn't apply to just the tool itself. For example, make package for Arch, which builds an Arch package, it also has an option sync deps to install the dependencies. That is implemented by shelling out to pacman. Because it just sells out to pacman, it will automatically invoke our script instead of the actual pacman, and all the dependencies will be installed into the image instead of trying to install into the host file system. So this makes it very easy for any tool that invokes DNF or apt or whatever. You can just run them. They will automatically use DNF to install into the image instead of to the host file system. So you can use various tools, whatever you want, without having to modify them. If you're doing very special stuff, it might not work. But for the basic use cases, this works great. We built sysext. So I mentioned base trees. So sysexts are basically a specialization of that. With sysext, you just want an overlay on top of the base tree. So we have an option called overlay. And if you enable that one, instead of copying the base tree and then installing extra stuff into it, we put an overlay on top of the base tree. And then we do exactly the same stuff we would normally do. At the end, we just take the overlay and we run repart with the overlay. So you're only packaging the diff on top of your base tree. You're not actually packaging the full image. And that's how you get a sysext. We do not, like Luca said in the sysext talk, we do not verify that you're only adding stuff to the base image yet. It would be very cool if OverlayFS had an option that only allowed files to be added and never to be changed or removed. So I would very much like an option that if you try to do that, when that mount option is enabled, to remove or change an existing file from a lower directory in the OverlayFS, that would just fail with EPERM or read-only EURFS. So that you can ensure that files are only ever added and never changed or removed. Now, even if we had that, it wouldn't work because all the package managers currently work by writing to their database inside the image, and all these databases are changed by modifying the database file. So it would be very cool if we had a package manager that could install new packages by adding an extra database file instead of modifying an existing one, because then we could enable that OverlayFS option if it were ever added, and we would have sysext that ensure that there are only ever files added and not modified or changed or removed. Initrds. So Shibishek came up with the mkosi initrd project to build initrds with mkosi, and that made me think, why should it be a separate project? We can just do it with mkosi or have it in mkosi itself. So we have an option make initrd, which basically it's very simple. It adds one symlink, which is the initrd release symlink, and suddenly your image is an initrd. Then you can also configure it as a CPIO, as the output format, and you suddenly have an initrd that you can use to build to build a UKI. So that comes in handy when building bootable images, because in the demo I just showed, we were first building the rootfs, and then we built the initRD. Okay. So basically, if there is, you can configure your own initRD, but if there is none, then we can build one automatically. We do this not by running Drake-it or anything else. We just use mkosi again, and it builds an initRD straight out of distribution packages. And it's exactly the same like a regular image, except for one additional symlink that marks it as an initRD. And this just works fine. Systemd perfectly supports this, so there is no need for Drake-it services or whatever, or configuration in an initRD. It all just works fine with regular systemd with a regular image. So everyone stop using Drake-it, I guess. These initRDs are a bit bigger than the Drake-it ones, so that's the only problem we still have to fix, especially on Arch Linux, because they don't divide their packages into sub-packages. The bootable images, so that's just using systemd repart. We generate the UKIs using UKify, and we have secure boot support, so you can specify secure boot key, secure boot certificate, and we will automatically sign things and set up secure boot auto-enrollment. So this is only supported by systemd boot, but basically if you enable secure boot and you then boot it in a VM, which is in setup mode, it will automatically enroll the keys from the ESP and then exit setup mode, so that without any interaction, you end up in a VM that is secure boot enabled with your own key without having to do any manual operation. So we now can build images, but for testing, it's also very useful to be able to boot them. So we have shell, boot, and QEMU verbs. Shell and boot are nspawn, so these translate directly to nspawn options. And then there is QEMU. So QEMU is the interesting one, because QEMU is the one you can run unprivileged. If you want to run nspawn, you still need root, but QEMU you can run unprivileged on most distributions. If you want to use KVM on Debian, you still need root. But on Fedora, you can just run it unprivileged. So you can build an image and then run it without ever needing root privileges, which is very nice if you don't want to enter your password all the time. For QEMU, we also support passing extra command line arguments and systemd credentials. So you have the credentials option to specify systemd credentials, and the kernel command line extra option to specify extra kernel command line arguments. This is very useful for debugging, because you can just add systemd log level equals debug, and you suddenly get all the debug logs. You can specify that they should be logged to the console, and you will get all of them in the serial console. And you can use that to debug various issues. And you can set any kernel command line this way, the ones picked up by the kernel, but also the ones picked up by systemd. So this gives you a very useful tool to runtime configure your image. So you do not need to rebuild your image to add kernel command line or credentials, which makes things very quick to debug, because you don't have to go through the entire cycle again. You can just at runtime set whatever you need. So Leonard explained this in his talk already. You can use a notify socket basically to get the exit status of your VM. So this requires passing a few things through. But the end result is that you have a service running in your VM, and it exits. That exit status is propagated through systemd, which then sends it over a VSOC to mkosi running on the host, and then mkosi exits with that exit status. So we think this can be very useful for running integration tests, because the tests can fail, and you can see that on the host, and also fail with that exit code. We still need to work on a good way to get the logs out as well without needing root. But we're thinking of adding something for this, and I actually think we might just use further.ofs to get the logs out these days. That would be the very simple solution. So that could be very useful for running integration tests. And we're planning to use this a lot more in systemd for integration tests as well. SSH, so we also do SSH over VSOC. This works really well, except there is one bug in OpenSSH that, because it tries to do a reverse DNS lookup of the host name, even if there is none, which times out on, well, if there is none. So it tries to resolve unknown, which doesn't exist. So it takes 30 seconds, and only then you get your shell. The fix is one line, which I proposed, and I also pushed it to the mailing, or I asked on the mailing list, please take a look at this. And of course, there was absolutely zero response. So if anyone knows an OpenSSH developer, please have them take a look. It would be nice to have that fixed. Currently, we work around it by disabling PAM, but it would be nice if we did not have to do that. We can build multiple images. So basically, you can build an initRD and then use that in your final image. This is when you do, the default initRD is not good enough, then you can just use a preset to build your own initRD. You can also build a base image that way. So what we do in the system configuration for mkosi is we first build a base image, and then we build the initRD and the main system off of that base image. The base image includes the latest version of systemd, built from source, and we need that in both the initRD and in the final system image. So we have the base image to share the work between the two. And then the initRD just adds a few packages and packages it up as a CPIO. And the system image makes it a whole bootable image. And then we can boot that in QEMU. So you can specify explicit dependencies between these two. So you have a dependency setting to specify which things depend on each other. This is very basic compared to a real build system. So if you had a real build system, you'd be able to do this in way more granular ways probably, and also have better checks on it. But this is like very useful for the simple scenarios. We have a GitHub action, so you can use this to run CI in GitHub. We use this for systemd, so it will basically install mkosi, make it available, and then you can just have your own configuration, ship with your repository, and you can run mkosi in GitHub CI with QEMU, everything, and it will just work. And we use this to test basically that the newest systemd version can be booted on all distributions in the mkosi images, and if it doesn't, then there's a bug, and we need to fix that. We're planning to use this a bit more as well to run all the integration tests in the future. So there's a few alternatives if you're interested in this space. Kiwi is the OpenSUSE one, and then OSBuild is the Red Hat one. Distro Builder comes from Alexi, and then there's a bunch of other tools for live ISOs. You can look into those if you're interested. What's missing? I really want to add bind mounts for QEMU, so use virtual more so that you can make your source code available in a VM, so you can run GDB or stuff like that. I also want to make it possible to actually deploy your mkosi images on your running system, so using systemd sysupdate. So that would basically allow you to run the whole image-based ID on your regular system. I think this could be very useful for community distributions like Arch and well, primarily Arch, I guess, and maybe Debian. Because you don't need the whole vendor signed stuff coming from your distribution. You just build the image yourself, you sign it with your own keys, and then you deploy it to your own machines. So you don't really need sysex or all of that other stuff. You decide what goes into your initRD, you decide what goes into your root file system, but you still get to use all this stuff without needing to go to the whole sysex thing because it needs to be signed by the vendor key. You have control over your own key, so you decide what goes into your image. And it's still secure, you have the verity protection and everything. So you have a very secure system without needing to be on a vendor-focused distribution. So that's something I want to add in the future as well. You can find it at systemd/mkosi, so it's not on the main repository. It's very easy to git clone and then just run from the repository directory. But it's also packaged in all the major distributions. If you have any extra feature requests, feel free to file them. We also have a matrix channel now, so you can also join there and ask questions. And I hope it can be a useful tool for you. Thanks for listening.
Any questions?
What's the multi-arch story for this?
So you can specify the architecture that you want to build for. It does need the QEMU user emulator installed. So we basically specify the architecture for the individual package manager, depending on how you do that. And then it will use the QEMU user mode emulation to run the post-install scripts. And all the other tools are architecture independent, more or less. So you can build AR64 images, for example, from an 86 host and boot them in QEMU.
Okay, thanks.
More questions?
And just a note on QEMU and KVM on Debian Dev KVM is a group owned by the group KVM, and you just need to be in this group, and then you also don't have to be root.
Yeah, what we do in the GitHub Action CI is we just chmod, we change the owner of that file, and then it works on privilege. So it's an easy fix, but by default, it does require root privileges.
More questions?
Would it be possible to, when you want to have logs from the QEMU process, to specify general D to just send it upstream through a VSOC?
Yeah, that's one thing we thought about too. Basically have the journal D tunnel it through a VSOC as well, and then have something listening on the host to receive the logs. But now that I think about it, if we just mount the virt.iofs at varlog journal, then we also get the logs out that way. So maybe that's just way simpler. It depends on the use case, I guess.
Anybody else have any question? Question? Going once, twice? Okay. Thank you very much, Dan.